In part B, I have you create a sign chart in problem number 1, and then in problem number 2, use that sign chart to solve the inequalities. So for part A, where it says x plus 4, x minus 4 is less than or equal to 0, first you have to identify the two most important points. And those are going to happen right here when x plus 4 is equal to 0. That'll be when x is negative 4. The second important point is going to happen right here. For x minus 4 equaling 0, x would have to be positive 4. Now it's very important that you don't just put these two numbers in the order that they just show up. You don't put negative 4 first because it came from the first factor. You put negative 4 first because negative 4 is smaller than positive 4. Remember, this sign chart is on a number line. This negative 4 is important because it makes the expression equal to 0. So I'm going to put a dot on negative 4. Positive 4 is important because it makes the expression also equal to 0. Next, we have to determine the sign of the function on each of these three intervals. So what I do is I pick a number that's on this interval, the interval for which x is smaller than negative 4. And I'm going to plug it in and see what I get. Now, I can pick any number that's less than negative 4, so I'm going to pick like negative a billion. And I do that because when I plug it in, negative a billion plus 4, I don't really care what the number is. This isn't a number chart, it's a sign chart. Negative a billion plus 4 is negative. And negative a billion minus 4, that's also negative. So I'm going to take a negative number and multiply it by a negative number, meaning that the result will be positive. Then I go ahead and pick a number that's in between, like 0. 0 plus 4 is positive. 0 minus 4 is negative. A positive times a negative is going to be negative. And then pick something that's greater than positive 4, like a billion. A billion plus 4 is positive, and a billion minus 4 is positive. A positive number times a positive number is positive. Now we can go back and look at the actual inequality and try and solve it. I want to know when is the product less than or equal to 0. Well, what's less than or equal to 0? Not the positive numbers, the negative numbers. That's what's less than or equal to 0. So my solution is going to be all of these, all of the numbers that are on this interval. So my solutions are when x is in between negative 4 and positive 4. And I look back and see, am I allowed to let x equal those things? Well, yeah, because the inequality does ask when is it less than or equal to 0. So I'm going to put the or equal to's on there as well. And this is our solution. So let's do it a few more times. In part B, I have x times x minus 6 is greater than or equal to 0. So first we identify the two most important points. That's going to happen when x is equal to 0 and when x plus 6 is equal to 0. So that's when x is equal to 6. 0 comes first, not because it was first, but because it's smaller than 6. Both 0 and 6 are important because they make the expression equal to 0. Now test each interval. Pick a number that's smaller than 0, like negative a billion. Negative a billion is negative, and negative a billion minus 6 is negative. Negative times negative is positive. Next, pick a number in between 0 and 6, like 1. 1 is positive, but 1 minus 6 is negative. Positive times negative is negative. Then pick something on the third interval, like a billion. A billion is positive, and a billion minus 6 is positive. Positive times positive is positive. Finally, answer the question, I want to know when is the product greater than or equal to 0? Well, positive numbers are greater than or equal to 0. So I want all my x's to be on this interval and this one over here. So my two solutions happen when x is less than or equal to 0 and when x is greater than or equal to positive 6. Now remember, I want to know when the product is positive, not when the x is positive. So that's why we end up with these two intervals, and why one of them is when x is actually negative. The last two have some visual things that are happening that make the problem maybe be a little bit more tricky. In part C, when I have negative 2 times x plus 1 times x minus 3 being less than 0, we want to find the most important points. And we think that this negative 2 has something to do with it, but there's nothing I can do to negative 2 in order to make it turn into 0. So I'm going to skip that one and go to the next factor, x plus 1. What's going to make x plus 1 equal to 0? Negative 1 is. And then I go to the third factor, x minus 3. And what makes x minus 3 equal to 0? Positive 3. Negative 1 and 3 are both important because they make my expression equal to 0. Now I go through and test each interval. If I test something smaller than negative 1, like negative a billion, negative 2 is always going to be negative, no matter what. And then when I use negative a billion plus 1 is negative, and negative a billion minus 3 is negative. So I'm taking a negative number times a negative number times another negative number. This time that product's going to be negative. When I pick something in between negative 1 and 3, like 0, negative 2 is always negative. 0 plus 1, that's positive, and 0 minus 3 is negative. Now the two negatives will cancel out, and I'll end up with a positive product. Finally, I pick something to the right of 3, like a billion. Negative 2 is always negative, a billion plus 1 is positive, and a billion minus 3 is positive. I'm left with the one extra negative, so this product will be negative. Now I'll go back and answer the question. I want to know, when is this product less than 0? Negative numbers are less than 0. That means these two intervals are going to be my solutions. The first interval is when x is less than negative 1. This time it's not going to be or equal to, because I just asked when is a product less than 0, not less than or equal to. The second interval is when x is greater than 3. Then the last one, this one's so tricky that it's got a little star by it. But first we identify our important numbers, and the only one is going to come from this x plus 6. So our important number is negative 6. That's going to make the expression equal to 0. I pick a number to the left. If I pick negative a billion, I'll pick something a little bit different this time to really illustrate it. I'm going to pick just negative 7. Right? All numbers on this interval are going to act the same. And if I plug negative 7 in there, negative 7 plus 6 squared, that's negative 1 squared. But anytime I square something, it's going to be positive. That means that all my numbers to the left of negative 6 are going to be positive. When I pick something to the right of negative 6, like 0, 0 plus 6, and I square that, that's going to be 6 squared, which is 36. Also positive. So, go back to the problem. It asks, when is this product greater than 0? When is it positive? All right. It looks like it's everywhere, but remember, it's not. There is this one time, right here, when x is negative 6, that it's not positive. It's not negative either. It's actually equal to 0. So, we have to identify each individual interval. That means I want my solution to be when x is less than 6 and when x is greater than 6. Of course, we could describe that another way. We could say that it's everything just when x is not equal to 6. That would also be a good way to answer this question.